Welcome to the launch of Houdini 18.5. So not much has changed since 18.0, except pretty much the entire world, and we hope you're really doing well as you can in these crazy times. I'm happy to say that at Side Effects, both the company and the team are both healthy and well. On the business side, what we're really missing is getting out and seeing you all face to face. But what that's enabled us to do is focus on digital events like the Worldwide Hive, the Game Dev Hive, and Houdini user groups from around the world. And so we've got dozens and dozens of amazing presentations by some of the world's top Houdini artists from all over, available on sideeffects.com today. Another area that we've been focusing on is learning material. And so mid-level material is what we've been focusing on because we've heard from you that that's an area that we needed to work on more. We have lots of great foundational getting started guides and some amazing master classes by the R&D team, but you wanted us to focus on that mid-level production type of material. And so you'll see lots of great new courses on character grooming, world building, destruction, Solaris, lighting, layout, and look dev, as well as shading and rendering in both Karma, as well as third-party renderers like RenderMan, Redshift, Arnold, and any third-party renderer that is a USD Hydra delegate. At the end of this month, we're hosting an 18.5 Hive, 2 days of learning with masterclasses from the developers, TDs, and artists who worked on the 18.5 features. On the software development side, we really haven't skipped a beat, and the R&D team has been as busy as ever, as you'll see today. To walk us through some of those new features, I'd like to welcome to the stage our VP of R&D, Kristen Barguil, and Senior Product Designer, Scott Keating.
Thank you, Chris, and welcome everyone to the release of Houdini 18.5, which is a minor release in name only. The past couple of years have seen the addition of some major new architectures to Houdini, like Vellum, like PDG, like Solaris. And it's all happened very fast to you, perhaps, and to us as well. Now, growing these foundations into rich environments takes time. It takes production feedback from you guys, and it takes steady focus from us. Which is why for 18.5, we've all hunkered down and put together an across-the-board set of enhancements for these three architectures and others as well, as you will see very soon. And while we did so, we were very happy to see how many of you already adopted Vellum and PDG and Solaris in your workflows and did things with them that we weren't even expecting. So that's fantastic. Let's talk about some themes for Houdini 18.5, at least two of them. One big theme is about high-level features. And that's building, whether it's Houdini digital assets or shelf tools or entire workflows with interactive viewport capabilities to help you not only accelerate your learning curve, but also sometimes shield you from the underlying framework should you choose to not go there at all. So whether you're building large-scale environments or lighting a huge scene or blowing up something big or clothing a character, you should find a quicker entry point into Houdini than ever before. The second big theme is about performance, and specifically interactive performance. That's leveraging the GPU and everything else that we can find to give you more of that real-time, or let's call it near real-time experience in your creative work, whether it's for dynamics or anything else. Now, the fact that Houdini has a finely tuned architecture that speaks directly to large scales and massive complexity should not and does not preclude it from giving you the fast performance where it can, as long as it continues to deliver value to you. This is particularly true with dynamics, where we have a lot of expertise, and our goal there is to turn it into an everything tool, if you will, a tool that you use not just for physical simulation, but interactively in other ways, say modeling, lighting, maybe rigging and animation. The edit SOP that you may recall from last year's reveal of Solaris was a prime example of that. And we're continuing that, and we want to do that in 18.5 and beyond. Finally, this release keeps with a recent tradition in Houdini of releasing a major new tool set every year, or at least once a year. In Houdini 18.5, we're particularly excited to announce that we are now tackling character. character workflows in their entirety, but not just as an added feature here and there, as a big platform-wide way. The name of that project is KinEffects, and that's a brand new foundation for everything to do with character, and it's all built into SOPs. So let's begin. In the works for several years now, KinEffects is our new procedural foundation for rigging, retargeting, motion editing, and more. It is implemented exclusively in SOPs with some VOPs mixed in. And key to it is the fact that joints and joint hierarchies, rigs, are expressed as points and edges, in fact, as regular geometry. This approach has several advantages, and I should mention as well that motion as well is expressed as geometry with no more chops involved. So this system has a number of advantages that Scott will get into in a minute. I'll mention just two of them. First one is that riggers instantly gain access to all the modeling toolset in SOPs. If you think about it, by putting everything in SOPs, rigging becomes a set of modeling operations. Okay. And the second advantage is that SOPs happen to be that environment in Houdini that everyone goes into and has fun. It's the easiest to understand, the easiest to become productive with. So these are two of the advantages I wanted to bring up, and the rest will come from Scott. Now, we refer to KinEffects in Houdini 18.5 as a foundation, but we're not delivering just a bare bones architecture. In fact, in this release, we bring you some sizable rigging capabilities, a toolset for retargeting and motion editing, and also enhanced I/O for mocap, imports, FBX, and game engine exports. And this is just the beginning. We see KinEffects as a continuum that will grow not just in the areas that I've mentioned, but also has a destination which is, as you might guess, it's character animation. In fact, it is the entire character pipeline. Scott, on to you.
KinEffects is our new procedural rigging, retargeting, and motion editing technology in Houdini 18.5. And when I say technology, I don't mean it's just sort of low-level nodes for doing small utility things. It's very functional, and you'll see that in just a second. But it really just that it's going to lay the groundwork for future work for a full character animation rigging pipeline in future releases. The key feature of KinEffects is that it takes rigging and character tools out of the object level and brings them into the geometry or SOP level. And there's a couple of reasons for this. One is sort of technological. We can have better performance in SOPs, but it's also in some ways just for the friendliness of the interface. Users are familiar with SOPs, and so they're familiar with doing the type of editing that you're going to want to do on characters using SOPs. But this will be a lot more clear when we start talking about some specifics. So let's just jump into some examples here. So let's just start with rigging. So here's like the most basic thing you can do. Here we are in SOPs. We have an FBX character, and you'll see this 3 input, 3 output sort of node. The first stream is the geometry, the second is the rest skeleton, and the third is the animated. There's no animation in this case. So we're going to put down a rig pose node, and suddenly you can see, we've got access to the skeleton in SOPs. We can move these joints around. We can position them by dragging the joints or by dragging on the links. So in SOPs, we're dealing with joints, not bones. The bones are more or less a visualization between the joints. And of course, this is not at all how an animator would want to work. But again, this is the groundwork for how an animator might interact with these types of tools in Houdini. So what is a SOP rig? So here's a really good example where we're starting with an L system, obviously not a character at all, just a bunch of points connected by polylines. But using the rig doctor, we can initialize these to essentially become a rig. A rig in Houdini are really just points with transforms and names. And suddenly, you open up this world of possibility of manipulating geometry using tools that are, really meant for character interactions, but not exclusively. including something like this. This is the full body IK solver. Again, it's happening directly in SOPs. And what's happening here is that we're manipulating these sort of target joints, and the solver is trying to pull the rest of the hierarchy toward it. We can do things like edit the weights on different parts of the rig or the skeleton. And so now you can see when we pull the limb, the trunk doesn't bend as much. And so this really opens up a lot of possibilities, because even though these are, in theory, character tools, they're really no different than other nodes in SOPs, meaning that they can interact with all the other tools in SOPs. So here we're just using, the Ray SOP, a very old SOP in Houdini, to kind of push the branches of this tree around. And so really the goal here is not so much just to take all the object level tools and bring them into SOPs just because people are more familiar there, but it's more about bringing all of the SOP tools into character. It's really about bringing those two worlds as close together as possible to open up possibilities that just weren't really there before. So not only do you have character tools, you now have all of the full arsenal of geometry editing tools in SOPs to help you manipulate your characters. And I think this is a really amazing foundation for the tools to come. Okay, so the first thing you're going to want to do, obviously, is have some animation. We even saw one of the inputs there was for animated geometry. So the first way to do that, the simplest way, is to do some retargeting from some motion capture. So let's, again, take a look at a very simple example here. We've got our demo character. We'll take a look at his underlying skeleton, and then we've brought in this walk animation. Now, these are different rigs. You can see that they don't have the same number of bones. They're shaped slightly differently. So we're going to use a tool called the rig match pose. And basically all we want to do is more or less line up the joint angles. And, it would be better if this animation had a rest position like a T-pose, but it's okay. We can use this match pose to try and get these angles to line up. Obviously, these characters are different sizes. The skeletons are not the same size, but we just want to get things in the ballpark. We don't have to be that close, but it'll allow our rig solver, our full body IK solver, to have an easier time of manipulating these. The next thing we want to do is map these joints. So right now they're kind of lined up, but we want to say which joint is driving which. So we'll just go ahead and use this interactive state to click and drag from one rig to the other, one skeleton to the other, to define which pieces of the rig align with which pieces of the other rig or the other skeleton. You can see that we're mirroring this, so as I'm drawing out one knee, the other one is automatically assigned. And this is, a very quick setup. Now, the interesting thing is that if this was done procedurally, you actually could have a hero rig and a standard mocap rig and drive all this just by name attributes. But the interactive state is nice for fast setups. And so right away, we've got the full body IK solver now using those goal positions to animate our skeleton, our original skeleton. You can see there's some issues with the shoulders kind of collapsed. So let's go ahead and fix the clavicles basically by reconnecting them here, just to give a little more information to the solver and let it do a little bit of a better job with those joints that we didn't assign. And you can see that this is a sparse solving, right? We haven't actually included much of the spine, but the solver is able to sort of walk through the hierarchy and still animate all of the joints along the way. So, okay, we've got a character, we've put some animation on there in just a handful of nodes. And you can start to see now how we can build up these SOP networks to do interesting, more complex things than just grabbing a handle and moving it. And of course, these rigs don't have to be very close to each other at all. So on the far right there, we have the target rig, this blue skeleton, which is just some mocap animation. Then the green is a very, very different rig with these huge arms, retargeted. And then the final character is actually an interesting hybrid where the overall animation is coming from the underlying skeleton, but the animation on the arms is actually being driven by the chain SOP, which we talked about in the modeling section, or we will talk about in the modeling section. And so you can really start to get this truly hybrid idea that a rig now is just geometry with a transform and positions changing. And suddenly this is going to open up a lot of really interesting possibilities for the future. And just to drive home the idea that the rigs do not have to really be very close together at all, here are some Paragon characters, courtesy of Epic Games, where we're driving them via the mocap. And you can see these wildly different body types and body size being driven by this underlying motion capture data, and giving you really nice, clean results, even on, like, again, wildly different characters, like this guy riding his robot lizard dinosaur. Really, really interesting and really flexible. And I think it really shows the power of this workflow. So motion. So obviously, motion takes place over time. And if you're familiar with SOPs, you'll know that there really isn't an idea of time in SOPs. Everything sort of lives in its own timeless space in a way. And typically, if you want to deal with time, you would introduce something like a chop network, one of the older networks in Houdini. But we wanted to avoid that because chops is complex, and it's a bit alienating for people to use. So it brought up the idea, well, how do we get time into SOPs if it sort of inherently is timeless? And that brings us to this concept of a motion clip. So on the bottom there, you just see our standard animation. We've got a walk, or a start walk, a walk, and a stop walk. And we want to deal with these pieces over time. So we can use a node called motion clip. And this is sort of a very interesting concept where basically the way we deal with time in SOPs is by turning it into geometry. So we're actually taking space-time and turning it into a piece of geometry that can be manipulated using the standard nodes in Houdini. So we'll do that for our start walk and our stop walk, and we'll use this node called motion clip sequence. The nice thing is we can use a locomotion joint now to blend these two clips together. So you can see the blue and the green being blended together over that period. So now the start walk and the walk animation actually blend into each other. And we can do this because we're really just looking at geometry placed in space, in sort of world space. And this gives us the ability to basically manipulate time by manipulating geometry. So let's take this a little further now. We'll actually create a sequence out of the walking animation, so we get a few cycles of walks. And then we'll just do the third thing for the same thing for our third animation, and blend those together as well. So again, just grab the locomotion joint, move it to the end, and you can see that by using this joint, we're able to place them correctly in space. If we didn't do this, they would all sit together on top of each other. And now you can see the three sequences lining up directly to the skeletons and the motion clips that are driving them. This is an extremely powerful concept, and it actually is the underlying technology for a lot of the geometry manipulation that you'll see moving forward here. So here's the result of what we just did. Not the greatest animation in the world. There's some issues, and you can see this foot sort of sliding on the ground as the character walks forward. So let's take a look at how we can clean that up a bit. So here I've just brought in that same animation. You can see the foot sort of dragging and slipping. This is just the result of our previous setup. So let's see if we can fix that. So first of all, we'll go ahead and put down a stabilized joint node. And what this is going to let you do is select some joints to stabilize. In this case, we'll just grab the ankles. And you can see them turning red, and that means they're pinned at a certain point. And it's doing this by looking at the animation over time and figuring out when something stops and then starts moving again. And in this case, just to get that other foot that's really sliding, we're going to increase this. Now, in a real setup, you'd probably want to do a bit more finesse than this. This is a bit of a brute force approach. But you can see that red dot sticking, keeping everything still. So this actually isn't really doing the solve just yet. It's identifying the positions, it's moving the joints, but we don't want to do this sort of brute force. What we want to do is now do an actual solve on this to get the feet into the right position. So again, we'll use that full body IK solver, the same solver that we used for the retargeting, to solve just for the ankles and the waist. And now all the animation comes through, the feet are pinned, but it's still believable. Other joints are allowed to move more freely. It's not a rigid copying of animation, which I think is really important. It helps keep this really nice looking. And of course, with a little more work, retargeting, getting the hands in there, you can get some really nice walk cycle, feet locking to the ground, giving a really nice, believable result. And that includes terrain adaptation. So the same sort of set of techniques take that exact same animation and modify the entire skeleton to sort of have the character lean forward, lift their feet as they walk up the hill so they don't get sort of foot drag as the feet are projected to the surface. You can see the lean. And all underlying all of this is that same idea of using basically a motion clip, modifying the data, and then putting it back into the animation. So you can probably start to see now the possibilities that really open up when you start thinking about time as space, which I guess is a funny concept, but I think you can see where we're going with it. Here's just another example of two clips being blended together, this sort of drop kick and this running animation. And more or less, we do exactly the same thing. We take these two motion clips, we bring them together using a clip sequence, target the locomotion joint to make sure that they line up in space. And then immediately we can get a really nice, believable sequenced result of two animations playing back to back. Now, again, you want to massage this. You can go even further, blend things together, try and keep the feet locked, keep everything nicely, smoothly going together. But at the end of the day, it really is just this handful of nodes to get a really good result. But what about blending things together? So here we have these two completely different walk cycles. We have this person sort of walking in a circle and then this other skeleton doing a capoeira. So what if we wanted to actually blend these skeletons together? Well, if you just sort of naively do it and blend them together, you'll get something more or less like you would expect. We hit play, and as we blend between these two animations, it sort of glides through space until it gets to the other one. It's not very convincing, but it seems to be kind of working okay. But let's just grab a couple of the joints. So we're just going to grab the upper arms, and then we'll hit play. And now we can blend sort of in local space into world space. So now the upper body is doing the capoeira movement and the lower body is doing the walk in circles movement. And this is going to really open up a lot of possibilities because suddenly you can blend multiple motion clips together in different ways. So if you only have a small library of motion data, you can manufacture large sets of data by blending bits and pieces of the skeletons together to produce essentially new animations. And again, this is a single node, so you can imagine doing more work, adding more nodes to clean this up, the kinds of results you would be able to get. Another way of just driving home this idea of characters in SOPs is this is a character just walking forward. And we're going to go ahead and just draw a curve here. Again, this is not a special curve for characters. This is just the standard curve SOP. And then we'll put down the path deform node. Again, this is essentially a modeling node, a node for deforming things along a path. But we can go ahead and put the skeleton on this path. And suddenly, even though this node has nothing to do with animation, it doesn't really understand animation, it has nothing to do with rigging, it suddenly becomes an animator's tool. It becomes a way of moving a character in your scene, even making them walk in circles to give very nice, surprisingly clean results. And I think this is where this hybrid world of character tools, modeling tools, and essentially just geometry manipulation tools are going to open up like a huge world of possibilities for rigging. So let's just take a look at some examples here of the types of things you can do. So here we're using the full body IK node along with the new rig VOP node, where you can build constraints using VOP networks to create this sort of man fascinated by a glowing green sphere animation. But you can see colliding the fingers with the sphere, leaning back as the sphere gets too close, the elbows moving. You can create very subtle, interesting animations just by combining some very simple techniques together. And again, because this is in SOPs, all these the animations, the inputs can all change, and all of this would just sort of update. So adding a layer of proceduralism that wasn't really possible with object-level rigs without basically writing a lot of Python to support your efforts. Here now, the physical full body IK solver being used with a center of gravity. So the solver isn't just about grabbing joints and targeting them. It actually can basically behave as if the rig is trying to balance itself. So as we move this platform beneath it, there's no keyframe animation here whatsoever. The character is basically just trying to move its body to get its center of gravity to be where it needs to be to match the orientation of the legs. Really awesome to look at, fun to play with, and I think again, we're going to get some really awesome results out of this. And of course, as we've moved our solvers into SOPs, things like the vellum solver, suddenly become a rigging tool. Here we've got these little antennae attached to the helmet moving around, and that's basically taking some skeleton, some parts of the skeleton and turning them into a vellum sim. But I think this is a much more interesting example of where you could take this idea of a hybrid approach, where on the left we have, basically just pure input animation. The rope is purely animated, rotating around the hands with a simple constraint. And then on the right, you can see the foot stabilization, the foot planting for the feet to fix that issue, and then the rope using collision detection and a vellum simulation. So, just to look at the underlying data here, suddenly you can fix all this animation and add a believable secondary motion to the rope just by including these simulated elements. So again, we're really bridging this gap between geometry and animation. In some ways, what we're trying to do is erase the distinction that a character in some ways it's modeling over time, and so you can start to think about it like that. And finally, here, just to wrap up, a question obviously: if we're doing all this motion retargeting, if we're doing work at SOPs, can we get these rigs into crowds? And of course the answer is yes, we can. So just to give you a quick example, we have nodes to help set these up. So we have the agent from rig node, and then the agent layer and some of the other nodes that have already existed previously for dealing with agents have been adapted to work with things like motion clips. And so it allows you to create agents out of this new sort of data type, these motion clips, which again suddenly means that even though we were targeting sort of character animation retargeting, it also opens up a whole lot of new possibilities for agents for crowd simulation. So here we turn this character now into an agent. But we can also go the opposite way. So here we have a crowd sim of these characters walking, and basically we want to do some editing to these characters. It's something that's sometimes called heroing out a character. So let's just grab these two characters that were just walking near each other in the crowd sim. You can also see the rig tree view popping open there for a moment, which is a nice sort of schematic view that lets you pick different parts of your rig. We're just going to isolate the arms. And again, you can see, a blast SOP, an edit SOP. These are just standard nodes in Houdini. We're going to basically move them together and copy over the positions. And then we'll use an IK solver in this case just to bring the hands together. And so suddenly now we've modified this this agent, or these two agents. So again, we have this two-way motion now between crowds into SOP rigging and KinEffects tools. So again, this is the foundational layer, but you can see how much functionality is already embedded there, how useful these tools will be. I think a really interesting fact is that I can imagine this actually being used for a lot of effects workflows, where suddenly you're adding essentially rigs to things like props or other effects elements. But of course, the future of this is animation, and this is coming down the road in future releases, where this base tool set will become wrapped up in tools to really become an animation and rigging tool set. Right now, we're very much focused on the rigging, retargeting, and motion editing. But absolutely, in the future, our goal is a full character pipeline using the KinEffects toolset. So every release of Houdini has somewhat of a focus on geometry and geometry processing, and Houdini 18.5 is no different. This is really because our surface operators or SOPs are really kind of almost the beating heart of Houdini. It's where a lot of the processing occurs. So let's take a look at some of what we've tackled here for 18.5. So modeling. Now in this case, modeling is being used maybe a little more generically, just to mean like creating things, putting things together, modifying geometry in interesting ways. So perhaps not so much on the traditional modeling front, even though there has been some work there. You're going to find a lot of, again, processing tools here in a sense, with a focus on usability and interaction. So right off the bat, we have this really awesome tool called Topo Transfer. And the idea here is basically that you have possibly a template mesh and then some sort of high-res or scan mesh. And really what you want to do is map one to the other. So maybe your template mesh already has really nice UVs, maybe it has really nice topology, and you want to conform it to this high-res mesh or scan mesh. And you can see we have this really nice state that lets you pick the points on one side or the other and switch back and forth between low and high res or template and target. And it gives you this sort of point cloud essentially that shows this mapping from one to the other. And the results can be quite nice. So even though this character, the scan data is holding this weight, its fingers are sort of interpenetrating the mesh, we're still able to get a really nice clean transfer from our template mesh to this high-res sort of scan data, even with all that sort of interpenetration on the hands holding the weight, or even the hands holding hands on the waist there. And so really, this is a nice way of getting geometry from one shape to another in a procedural kind of way. And of course, a lot of this can be driven by groups on the template mesh and groups on the high-res mesh. And you can imagine in the future, we want to automate even more of this process. Allow these targets to be discovered more automatically and do this pairing in a more procedural way. But I think even in the beginning here, you can see how nice the results already are using the new Topo Transfer node. And so polybevel, you've seen this come up multiple times over the years, and that's because we're always doing these improvements on this node. It's not sort of a finished node. We do a release. We get feedback. We try to match the expectations of users. And so again, we've done some improvements on the actual quality and output of the polybevel node, but we've also done some work on this idea of the interactive state. So a lot of times Houdini's nodes have this idea of make a selection and then apply the result or apply the operation to that selection. And what we're starting to experiment here with polybevel is the idea that the state kind of controls that interaction. So without having to make selections and then apply the result, you can sort of work in this interactive way. So polybevel here now is letting you sort of add and remove things to be polybeveled kind of all at the same time in this tool. And I think it really just frees you up as a modeler to not have to sort of pre-plan everything that you're doing. Instead, you can work more spontaneously and make those selections as you go. And this is really the beginning, or at least another step on the road of trying to almost put an interactive layer on top of the sort of procedural engine that sort of drives Houdini, as I mentioned earlier. And this is another great example here from Side Effects Labs. This tool already is actually available to you, but I think it's a really good illustration of how we're taking these states and not only using them internally to do things, but allowing users to generate them themselves. So this is taking advantage of the new Python state API that was introduced a while back. And this kind of thing would have just been really almost impossible to do previously. But with Python handles, Python states, suddenly you can create, again, this very sort of direct modeling kind of operation and apply it to standard Houdini nodes. But now you suddenly have this really nice feeling of directly manipulating your geometry rather than the sort of hands-off approach that you might typically imagine from Houdini. And I think this is going to give us a really sort of bright future. It gives us a lot of possibility, again, internally to build these tools, but also for users out there to build their own tools, to build tools that really weren't possible until we added this sort of infrastructure for states, Python handles, and we're just going to sort of keep enriching that ecosystem as we move forward. Another tool that actually was released partway through the year is Path2Form. Path2Form, an extremely useful tool for deforming things along a path. And basically, we had this ready pretty early in the development cycle, and we thought, let's get this out there early, let people start using it. And I think it was a really sort of nice way of letting people sort of see what we're doing sort of mid-release, not necessarily tied directly to a release, but still a very useful, very powerful tool. And of course, all these handles, in this case, being driven by this same idea of a Python state. So again, letting you sort of work directly in the viewport, interactively, creating these types of deformations. So a cousin of the Path2Form is a new node that we're calling the chain SOP. And so what we're going to look at here is basically I've got several pieces of geometry. In this case, there's sort of an arm of a chair, then this sort of base theatrical chair, and then different versions with the seat up and down. Just imagine a bunch of pieces. And what the chain SOP will allow you to do is take that sort of library of pieces and then chain them together based on an input curve. And by chaining, we really mean like putting them together, so abutting them against each other. So we measure the shape of them, and then we align them. And there are actually a lot of options for how you align them based on either attributes or the bounding box. So you can create very complex sort of new pieces of geometry with interlocking pieces. And you can also see we're doing some of this weighting here to have more or less of certain pieces. So I'm just presenting more options, giving you more ability to work directly with those pieces, rather than having you have to sort of generate all these attributes up front, which we have a lot of tools to do, but we figured let's build it directly into the tool and make it a lot easier for people to get this far. You also see that it's quite efficient, so we can create a very large group of these chairs. We're just using the bend SOP to bend the curve that they're sitting on. And you can see that with a copy SOP, we can create an entire theater's worth of chairs in just a couple of seconds with this really nice, complex interaction of all these random pieces. We're correctly putting, the sides on the chairs on the start and end of each row. And this is something that obviously you could have done previously, but it would have been a lot more work to figure out, well, how many rows or how many chairs per row? How do we make sure that these different pieces, press up against each other? And the chain SOP really handles all that for you. And here's another example with some different size pieces that you can see, and some of the other abilities to do this sort of almost interactive building of these chains just by using a stroke SOP or a draw curve as the input. And then, of course, because it takes curves as inputs, there's no reason you can't just go ahead and run a simulation on those curves before you do the actual chaining. And that gives you the ability to have these really awesome results where you have this wonderful animation, but still this really interesting, very intricate piece of connecting geometry that, again, absolutely was possible in the past, but quite challenging to set up on your own. And this wraps it up into a really nice tool. And in fact, along with Path2Form and some of the other tools that we already talked about, gives you this really rich ability to suddenly take a few pieces of geometry and turn them into very complex outputs. And speaking of that, let's take a look at environments. So again, here we're not necessarily talking about actually generating the environment itself. This is about dealing with environments. And one of the key things that comes up with an environment is scattering things. And we've had some scattering tools for a long time, but in 18.5, we've added a new node called scatter and align. And this basically takes a couple of tools and combines them into something new. More or less, it scatters points, does it in a really interesting way based on the coverage to sort of pack them together tightly, and then provides a lot of options for how to create the attributes that drive the alignment of things that will be copied later. Here you can see that we can offset the angle, we can set a min and max angle, we can scatter the pieces over the surface, align them in different ways. And this gives you a lot of potential. But with all these tools, whenever we talk about simplifying something or making something more accessible, I want to be clear that that doesn't mean removing any of the power. All of these tools still accept attributes. They still accept inputs, totally procedural inputs. And so the idea is to just make it easier to get started, but not cover up or hide any of the power that Houdini is known for with these procedural setups. So here we're just using the comb sop to drive a normal attribute on the points, and then using scatter and align to those points. And it gives you this really nice way of sort of painting a direction onto a surface. So what about the things you're going to put on those points? So here's just a quick example of a tool that basically gives you a bunch of different patterns, essentially, to take pieces and put them on points. And let's take a little bit of a closer look here. So the node is called attribute from pieces, and it essentially creates the attribute you need to copy the correct piece onto the correct point. So we have a bunch of different really useful ways of doing that. This is the patches method, which basically gives you almost these clumps of similar assets together. There's noise, and we're all probably pretty familiar with noise, and it can be really useful for creating sort of natural looking patterns, and obviously using ramps and roughness and distortion can give you a really natural look. And then there's randomness, which is obviously used quite a bit. But something interesting here, much like the chainsaw, is we've added this ability to find the pieces, populate this interface, and then allow you to weight them. Because the reality is, on environments, most things aren't truly random. There is some organization. Maybe there's more grass than there's trees, and so on. And so this gives you the ability to really customize what your distribution will look like. And then this is an example of let's say we haven't provided you with the tool that you need. Well, you can actually just use a vexpression to drive it directly. So we've simplified the number of pieces here a bit just to make it clear. But basically, we're going to say, hey, let's put all of the blue flowers on the negative x-axis and all of these bushes below the z-axis. And then we'll do the opposite for these buttercups. And you can see we get this really interesting mix of these pieces scattered, or at least assigned to the points on, in this case, a grid, but obviously it could be a terrain. And we can go even a bit further with that by actually directly mapping to an attribute. So in this case, we're just showing this sort of circles, the template, with a p-scale assigned. In this case, we're going to use these trees and scatter them or assign them to each point. But what we're actually doing, you can see with these sliders, is mapping a range of values to a range of pieces. So, the trees are bigger, so they go to the higher end of the p-scale. The weeds and clovers and so on are on the small end. And so that gives you this ability to create this really nice distribution where you're mapping values one to the other, pieces to ranges, and suddenly it gives you a lot of possibilities. Now, we're using p-scale in this example just because it's sort of very obvious, but it could also be something like how arid the soil is, or maybe any other sort of terrain attribute where you want to control the distribution of instances compared to some attribute on your geometry. And so far we've shown these sort of small scale examples to some degree, but let's take a look now of doing something like a city. So again, the scatter and align, feeding into attribute from pieces, feeding into a copy to points. So a very familiar workflow, just with a nice sort of wrapper around it. Here's a really nice example of an option on the scatter and align, which is to round to multiples of a number. So in the case of a city like this, you want these sort of right angles. You don't want a fully random city because that's not really how things tend to look. And then, of course, because we're using packed geometry, you can see how efficiently we can create this large-scale sort of cityscape in just a handful of nodes. And if we zoom out, you can see just how big we actually made this city. So again, we're taking familiar tools, providing new interfaces and new possibilities. So it isn't just about putting a wrapper around an existing set of tools or an existing set of nodes. It's about providing a new way of thinking about these nodes and a new way of interacting with them to broaden the possibilities and allow you to work just more efficiently inside this context of scattering and aligning. But so far, we've just been doing sort of a blind scatter, just taking points and putting them on things. But we wanted to also give you nice ways of sort of assigning where those points should go. So we have this new node called mask by feature. And it kind of looks like it's doing some sort of lighting, like baking lighting into an attribute. And it kind of is. But really what we're doing here is saying, let's create a mask for things that are facing a certain direction or are occluded from that direction. Or in the case of ambient occlusion, actually occluded sort of in a hemisphere almost. And these three sort of possibilities can be used in really interesting ways to scatter points. So let's just go ahead and use a scatter and align here. And we'll just put our mask attribute as the coverage attribute. And you can see right away we're getting some interesting effect where points are kind of avoiding the bases of objects as if they're sort of in shadow. Or we can obviously invert that and say, like, no, we want things that are close together, things that are living in the shadows or living near the base of things. And here we're just interactively adjusting the direction to show you how all of these masks sort of combine together. And you can start to imagine interesting possibilities where maybe certain types of things like to live in the shadows of other things, or maybe you want to put objects within the crevices or cracks of other things. And a tool like this allows you to A, generate the mask, and B, send that downstream into the tools that we've already described, like scatter and align. So let's take a look here at an example. So we're just going to walk through this scene, but basically we're just going to create a mask, in this case close to the objects here. And what we want to do is take that and put a library of, in this case, rocks around there. So he kind of helps embed those sort of template geometry into the environment a bit more. And here we're almost just inverting it and saying, like, we want the trees to grow, but nowhere near the other objects. Give them a lot of space, kind of push them out to the edges. Then the bushes kind of live in between there somewhere, between the rocks and the trees. And then the flowers want to live in between those things. And then finally, things like moss or clover sitting entirely on the tops of geometry. So very quickly, you can see essentially the same operation 4 or 5 times in a row. You can build up what is almost sort of an ecosystem that really gives you a nice believable result, a nice sort of full result with a lot of control. You have each of these masks just feeding into the other down the line. And of course, this is a simple example. Here's just sort of a nice OpenGL flipbook using some of our new fog and depth of field just to make it look spooky, I guess. But you can see it gives this really nice natural result. But it's not all about these small scale scenes, of course. We want to have large scale things. So this is just an example of a large terrain, but essentially doing the same operation. You're just using masks and using these scattering tools to take useful information from the terrain or your environment to drive these processes. So it's about finding the useful pieces of information and then feeding them into the tools that do the scattering. So here's a tool from Side Effects Labs that's really interesting because in some ways it's on the opposite end of the spectrum. It's about actually just placing by hand, in this case, rocks in your environment. And you can see pick and place, as the node is called, lets you really rapidly build up, really hand-generated content here. You're placing these things exactly where you want them. And so some ways on the opposite end of the spectrum from the tools we talked about before. But of course, this could become the input to those tools. So I feel like we're finding a really nice balance now between procedural tools that can take away, the work of doing huge amounts of things, large-scale environments, large-scale scattering. That's just not really practical to do by hand. And then tools like this, again, using that same Python API, Python handles to build tools for artists to feel like they are directly influencing or art directing the result. So we're sort of living on a spectrum now between fully art directable, fully in control of the artist, sort of one-to-one interactive state versus a tool that ingests geometry, processes it, interrogates it for useful information, and then exports an interesting result. And here's just the sort of end result of this image, looking quite nice. So Solaris. So obviously Solaris joined the ranks of Houdini in version 18, and it was a big push, a brand new sort of architecture within Houdini. And a lot of the work that we did was about taking USD and everything that USD provides and providing those same tools to Houdini users in a procedural network. So almost a procedural wrapper on top of USD. And so what 18.5 is really about is finishing that work, but also then starting to provide tools to help people work at a higher level than directly with the USD itself, and to sort of wrap up those tools in a way that makes Solaris easier to work with, so that the artist can be more productive as they do so. So let's start with variants. Variants are this really awesome idea where I can have, multiple things in one primitive. So in this case, again, going back to this theater seat. So we have a variant for each type of piece of seat, but you only really see one at a time. It's hard to see what variants exist on a primitive. And so the new Explore Variants LOP allows you to basically see all the variants all at once. And this can be used to just explore the variants as it's suggested, or to actually pick one. So you can pick from an actual visual sort of representation of the variants rather than trying to go by a name. And if you imagine you have 50 variants, it could be quite tedious to find the right one. You can also duplicate the variants. So what this does is, instead of just setting one variant, it takes whatever variants you've selected and basically creates new primitives for each of them. And where this can be really handy is when you want to do something like this, like scatter or copy those variants to chairs. So use the variant to store all your variations of each instance, and then the Explore Variants node to actually create a primitive for every one of those and apply those as a prototype, essentially, to your instancing operation. And you can see here in the scene graph tree over there how we've taken the original seat and then broken it into every possible variant within it. Really useful tool, really nice way to find variants and work with variants without having to deal directly with the paths and primitive names. Something else we've done is taken the edit lop. Now the edit lop is really useful, obviously, for editing things, moving them around. And we've basically improved performance, we've improved the handles, we've improved the way you interact with it. But something else is that we've added this new interface that lets you see the operations that you've done. So you can see I moved two objects. Here are the transform values. And I can even do things like disable or enable the actions that I've done. And so, the edit lop was sort of an opaque tool. You did these actions, but over time it would be easy to lose what you did at any given time. And this new interface allows you to sort of see the results. You can type them into that interface. And it's a really nice way of sort of keeping track and organizing your edits. And this, of course, also applies to other types of editing. In this case, we're going to take a look at maybe doing some physical editing. And so we can do things like, for instance, show all of the primitives. So now, instead of having to select from the viewport, I can select directly from this tool on the side, filter it, do things like add physics to those pieces. And basically, again, it gives you this nice little layer on top of what you're normally used to give you an idea of what pieces have been selected, what am I actually doing at any given time. And again, this is essentially the same node in a lot of ways, but by adding this extra layer of interface on top, it suddenly makes it more comfortable to use for an artist, especially as someone who might be tweaking and editing a scene like this over a long period of time. So these tools, seeing what's selected, filtering what's selected, allowing you to enable and disable things, really just smooths out that workflow and makes it feel like you're in more control than maybe you felt in the past. And of course, we can take this even further in Solaris and add new tools for dealing with destruction, for integrating rigid bodies into layout tasks or effects tasks, and to simplify this process. So we have a new rigid body destruction lock that helps you make sure you deal with all the intricacies of Solaris and USD, like maintaining the same number of primitives, things that are difficult to deal with on your own, just wrapped up into a new node. And this editing capability has now been expanded into the light mixer. So we can take a look at creating lights from within the light mixer here. We're just going to set a color to it. And you'll see that what's happened is that it's created in this subnet directly above the light mixer. So now all your lights go into one place. You're not sort of hunting all over your network to deal with them. And not only that, it also allows you to manipulate them using the light state from the light mixer. So again, you're not required to go to the actual node that set up the light. The light mixer itself has sort of inherited that state. This now gives you the ability to basically create lights, edit lights. You can see the same sort of view as the edit state here embedded now into the light mixer. So it gives you basically a sort of a one-stop for all the things you might want to do with your lights in a scene. But the nice thing is that it is still generating the network for you. So even though this tool sort of existed previously in bits and pieces, what we've done is brought all of those disparate elements together, put them in one place so that editing lights, manipulating lights, creating lights, all sort of are driven by almost this one control panel. And this then makes you feel like you're in more control, unless you focus on your work, which in this case is lighting, and it keeps you from having to focus too much on the network itself, and instead lets you just be an artist, place lights, make things look nice. So what about dealing with multiple shots? So in this case, we have this network, very simple. We have 3 different cameras. We can jump to each chain in this network and look from a different camera. But you can imagine that's kind of tedious. It means you have to move display flags. You have to jump around. So let's start off with adding some nodes that can help with this. So we're going to start with a render settings node. And this existed previously in Solaris, but what we've now added is the ability to use the settings prim to drive the camera. So we're now just going to move shot to shot, and automatically we just pick up the correct camera. We don't have to select it every time. So that's a useful capability. We can tie that in with a switch SOP, and now we can sort of drive that using a switch. But all of this still means like sort of tending to your network, really paying attention to what node is selected, where I'm looking. So we've added some new options to the Edit Context Options node, which basically allows you to use a couple of different ways. In this example, we're going to use time-based options. So essentially, I'm just going to set up our 3 shots using these frame ranges. So shot 1 is 1 to 80, shot 2 is 81 to 160, and shot 3 is 160 to 240. And once we've set up these variables in this sort of pattern, we can go to our switch now and just use the @shot variable to grab those values based on the time. So maybe it's easier if we just play this and see how it works. So now as I change my frame range, you see the camera automatically changes. So I no longer have to actually go to the node. I no longer have to worry about my network so much. Once it's set up, I can now work more freely just by changing to the correct part of the timeline where my shot takes place. But let's take this even a little bit further than that. So again, we've got this sort of nice little setup now. But what about when I want to add nodes into this network? I still need to sort of know where to go. I need to jump to the correct place in the network. So we've introduced this idea of an insertion point. And this is essentially a named node. And the names can actually be the same in different chains. So in this case, we've set up sequence lighting and shot lighting. And now we have this nice menu in the viewport that lets you pick your target. So let's start with sequence lighting. And you'll see now that if I type dome light, the node is automatically added above that insertion point. I didn't have to go into the network to drop it. My display flag is still at the bottom of my network. So it lets you see the result. It lets you see your shot sort of in context, and frees you up from having to sort of jump to those specific parts of your network. So now let's switch to shot lighting. And we'll move to our third shot just by changing the timeline. So if I add a light now, you see it automatically went into that chain on the right for shot 3, just because it understands the context option that's driving it. So the insertion points are sort of aware of this path. They're aware of the cook path. So that light did not show up in shot 1 or 2, only in shot 3. Let's jump back to shot 1. We'll go ahead and add a light here. And I'm really just making these exaggerated lights just so it's really clear which shot we're in. But you can imagine now that, we're showing sequence lighting and shot lighting, but this actually applies to any sort of task within your network. Also, a nice little action here is that radial menus can dynamically pick up the insertion points. And not only pick them up, it will let you select them. So you have the menus, you have radial menus, you have our new light handles that let you change the size of lights. So really now what we've added is almost an ability to target your specific task. Whether it's lighting, effects, characters, whatever piece of your network you need to work in, you can select an insertion point, automatically start placing nodes there. And it gives you a really nice way to have almost a template, a layout for your network, and almost fill in the pieces as you go, rather than constantly having to kind of babysit the network and add these nodes. Just as an aside, since we talked about the radial menus, the dynamic radial menus, we've also added the ability for radial menus to exist in the network editor. So here we're just looking at one of our default navigation radial menus that lets you jump up and down networks, jump to different parts of your network. And so adding this ability into the network really gives you a nice way of having these tools that exist in different places that give you the functionality you need for that specific environment. Just a nice little update, and I think we can really use this to some powerful results down the road. Okay, so let's take a look at sort of a lighting task here. We've got just a bunch of lights feeding into a light mixer. And let's go ahead and just make some changes here. I do have the optics denoiser turned on in the viewport just to give us sort of fast results. Now let's say I like this result, but I want to do some tweaking of our lights. Well, now with the new render gallery, I can pop it open, I can make a snapshot of that gallery, and then I'm safe to go ahead and make some tweaks. So, I've moved to a different lighting setup here. We have this sort of spotlight, we have this rim light, and we want to now go ahead and add another snapshot of that so we can keep track of these. And now for this third setup, let's say I really increase that lighting on the back wall, and I decide I don't need any of these lights. These are superfluous, so I'll just delete them from the network. And then I'll go ahead and create another snapshot. So we have these 3 different versions now. Then we can go to the render gallery viewer and go ahead and look at these objects or these images and compare them. But we can go further than that. We can set an A and a B version, and then we can sort of swipe between those images to compare them directly. And this can be really nice when you're doing sort of small tweaks. Of course, in this example, these are very extremely different, but I think you understand where the idea goes. And now let's say you have a lot of these things. You can star them and filter for that star, so find the ones that you think are good. You can actually name your snapshots. And then we have a more advanced filter possible as well. So let's go ahead and filter for things that have a star or things that are spooky. So I'll just go ahead and type spooky into our filter there and say any of those. And so now we've filtered those to just that selection of images. So let's say I've decided that I actually prefer this, but the network is different now. So I can actually use revert to network to go back to the state of the network at the time I took that snapshot. And that works the other way as well. I can go back to this edited network. So the render gallery has a lot of functionality embedded into it. And it's really designed to let you work as sort of naturally as possible. Create the snapshots when you need them, automatically create them based on time periods. We tag them with things like the date and so on, so you can always find them. And not only that, I think a really important feature is free you up as an artist not to be concerned with, oh, I made a tweak and I don't actually like it. I need to go back to where I was, but that's been lost. Each of these snapshots actually stores your network, the state of your network. So you can actually freely make large-scale changes without fear of sort of ruining the result or losing the result you wanted before. So, and this is kind of what I was talking about earlier when we said, version 18 of Solaris was about introducing all the features. And 18.5 is sort of the next step where we're now saying like, okay, now let's make artists' lives a bit easier. Let's make it nicer to actually work within this context. We've also added some features to the viewport itself just to make things feel a little nicer when you're actually just using GL before you actually render anything. So here's just a little animation of sort of racking focus from foreground to background using the new depth of field in our viewport. Here you can see some bokeh options with the lights in the background sort of blooming and showing that actual shape of the camera aperture back there. So again, you can get some really nice looking results just in OpenGL, which can be a nice guide for your final rendering. We also added volumetric fog support, so you can have God rays, the sort of glowing, very spectacular looking results in your viewport. And this is just an OpenGL effect, of course. This won't necessarily match one-to-one with whatever volumes you may be rendering using Karma, but it lets you sort of get into the zone, get into the idea, and certainly see where light is being cast within your scene. So again, it's about visualizing things to get you as close as you can to the render result as possible. In this case, it also just looks cool. So Karma is still in beta. And so let's just take a second to talk about why that beta tag still exists. And essentially it exists because we're not fully at feature parity with Mantra, which is where we want to be before we come out of beta. But we're getting there. Fur support has sort of come online. Really nice results. Of course, they won't be identical to Mantra. This is a different renderer. But the idea is to get up to that production quality renderer. And we're starting to get there. We're getting some really nice results. We've also added some nice extra features so that, for instance, if you want to render to mplay, you can use this interactively. It will progressively render and let you click in areas to focus the results. So something similar to the old render view that Mantra used to have. Sort of a Karma version of this, where you see this progressive image, allows you to focus on different areas, and you can see some really nice results here from this awesome curly-haired pig. So here's an example of something that we couldn't do before in Karma, which is this rounded edge shader, and that was because there was a Vex function called trace, which wasn't available in Karma. And now we have some limited support for that. And when I say limited, something I want to be clear about is that Karma is a new architecture. The goal of Karma is to be a modern production renderer. And that means not everything from Mantra can come across, because some of the things Mantra could do are also some of the things that held it back in terms of performance and scalability. So it's a balance between matching old options, but also being a very contemporary, modern renderer. And on that road, we've also added something called physical lens shader. So here's an example where basically what we're doing is creating a focal plane using this tool. So you can imagine this as basically a tilt shift lens. And the really nice thing is that we're doing this interactively. So the shader is being modified by picking these 3 points on the geometry. And you can see you can tweak it very closely and align that focus plane exactly as you want in this sort of way where it's, in this case, aligned to sort of the head of this mechanical object here. But the lens shader has other options. It's not just the tilt shift. You can see the shader itself has lens distortion, for instance. So you can add chromatic aberration to give that sort of quality of maybe a cheaper lens, or this standard sort of fringing you might see on the outside of the outer edges of real physical lenses. We can also distort the curvature by using a texture map or a ramp to sort of change essentially the shape of the lens over the surface. So lots of really interesting possibilities here to take your renders to kind of an interesting new level where you're actually creating different lens effects to get the result that you want. And then here is an early tech preview of the Karma GPU engine. So again, this is all sort of running in real time here. You can see we're changing lights, we're moving the camera, it's rendering progressively this whole time. You can grab this light and move it around. You get really nice, fast, interactive, high-quality results. These are very promising results. I do want to stress, of course, this is an early tech preview. This is still, down the road, but we've got a lot of progress made. We can bring in USD, we can render it, we can move lights. So we're really coming along. We've come a long way. In fact, let's take a look at the theater that we were showing before. And again, this is that sort of worst case scenario for a ray tracer where the scene is almost entirely lit from outside. There are no lights on the interior of this space, but you can still see how quickly it resolves to a clean image. I think in our tests, it takes maybe a minute to get to a very clean image, whereas Karma was taking around 27 minutes to get to a clean image. Not exactly a one-to-one comparison. Obviously, there are no texture maps here. There's less information, but still, again, a very promising result. And now a GPU volumetric rendering happening here. Really, really nice. You can see interactive results. We can move these lights around more or less in real time, get remarkably clean results, even while playing the animation back. So, we're really pushing what we can do with this technology to give a really nice, clean render very rapidly. Once again, I just do want to stress that this is an early tech preview before you get too excited, but I think the future here for GPU rendering is bright. So conduits. This is really our way of just describing how Houdini can sort of pass information back and forth to other pieces of software. Obviously, Houdini Engine started all this with the idea of taking a Houdini asset and bringing it into another piece of software like Unreal or Unity or Maya. And we're really trying to expand on that and what that can actually even mean. So let's take a look at just some examples of exactly what we mean by conduits. So the Unreal Engine 4 plugin version 2.0, still in beta, is a really good example of where we can take some of this. Obviously, the plugins, these are essentially Houdini Engine plugins, but they've expanded their capabilities quite a bit. So with Unreal, we can access blueprints now, world composition. A lot of features that were sort of out of reach of the previous plugin are available in the version 2.0. And of course, we're aiming for a December 2020 release for version 2.0. But let's take a closer look at some of the actual features here. So first of all is just the speed of processing. Things generally update much faster. You get a much more responsive result, which is obviously key when you're playing with parameters like this. And part of how we've accomplished that is with proxy meshes being much, much faster. So as you're playing with results, you start to see results much quicker. You can see in the version 1 of the plugin, it can take a long time to update a complex mesh. And with this new proxy mesh, you can get 6, 7, 8 times faster results than you could previously in the old plugin, which is really nice because it means that it feels more like the plugin is really part of your work as you're working in Unreal. Along those same lines are what are called brushes in Unreal, these BSP brushes, which are sort of a fundamental building block of a scene in Unreal. And previously, we couldn't really interact with those with Houdini Engine or with the Unreal plugin. Everything had to be converted to a static mesh. But now we can directly interface with those brushes to create these sort of hybrid tools where you block out the base shape with these brushes, and then Houdini Engine processes it into something sort of more complete, which I think is really interesting. It opens up a lot of possibilities for how you build these tools in Houdini for Unreal. Here is PDG interacting with Unreal. So in this case, we're basically pre-processing these desert tiles. And you can see that now we're bringing them in, and World Composition is able to pick those up. So Unreal World Composition handling the streaming of this data. So pre-processing using PDG, and then using the results in the World Composition in Unreal to get this sort of streaming data, which is, again, really nice. Using PDG exactly what it should be used for, which is processing massive amounts of data as quickly as possible by distributing it, and now bringing it into Unreal and giving us access to the world composition gives this really nice feeling, again, of these two worlds coming closer together. Unreal and Houdini getting closer together as a tool. And along those same lines is this sort of live link that's being demonstrated here. Here we have Luis wearing the Axis Neuron motion capture sort of harness, going into the capturing software, being brought into Houdini, all live. This is a live sort of real-time recording of this session. And then the interesting thing is that in Houdini, we're processing it using the new KinEffects tools and then going into Unreal. So again, we're trying to create this world where you can seamlessly move between these spaces, where even live, you can take data, process it, and bring it into Unreal. So you see the processing happening in Houdini and the output happening more or less in real time all the way into Unreal, which I think is really, really powerful and opens up a lot of potential, especially when you start talking about characters. And now there's services. And by services, we kind of mean, again, using Houdini not just as like, well, I have an HDA and I want to embed it in a piece of software, but instead allowing more communication between these different pieces of software and allowing them to sort of reach out and get information from Houdini, or for Houdini to pass information downstream without it being necessarily directly about an HDA, directly about cooking a node. Again, probably more clear if we take a look at what I mean with a little example here. So if you imagine that we have Houdini Engine, we have PDG, we have Houdini itself, and what this idea of Houdini as a service means is that you can access not just the sort of geometry processing plugins, but things like HOM, things like a web server, which is something we're talking about here today, and then combining them in different and interesting ways. Think of PDG in the cloud. There's lots of ways Houdini can be used beyond simply cooking a node. And what Houdini as a service sort of opens up is this sort of wide world of possibilities where you're using the Python API for Houdini Engine, the HOM Python API for Houdini itself, combining them together, communicating outside of Houdini. But again, let's just take a look at some examples of what this might mean. Here's an example of something called session sync. And basically, session sync is, again, using this idea of communication beyond simply cooking a node. Here on the right side, we have Unreal. We're changing the parameters, and sort of in sync, there is a Houdini session running that is picking up those changes and applying them to the network. And of course, the opposite is true as well. Change the Houdini parameters and the Unreal session update. So in some ways, this is an expanded version of the debugging tool that we had before, but that was a very static workflow, whereas here it's very much live. You're directly interacting on one side or the other. So multiple hosts can connect to a Houdini session. You get this live session sync. And again, this opens up a lot of interesting possibilities because you can work with the network. This isn't, again, it's not just cooking a HDA. You're actually sending this information as you're building it. So as you build your network in Houdini, you start to see the results inside of the Unreal Engine, which again was not really possible at all to do before. And again, opens up this feeling that Houdini now is communicating all of the possibilities of Houdini, not just a node being cooked as if you were pressing a button. Taking it even further, we've got Unreal and Houdini synced here, even to the camera. So we can manipulate the handles in Houdini and see the result in Unreal, but we can also manipulate the camera in Houdini and see the results in Unreal. So the idea of a session sync is really true. You're really keeping things in sync as much as possible so that it really feels like you're manipulating both things at the same time somehow, which really makes it a almost truly hybrid sort of approach. Everything that you want from Houdini and everything you want from Unreal, communicating as much as possible back and forth. Of course, it's not just Unreal. Here is Unity doing a session sync as well. So as we manipulate this curve in Houdini on the upper left, you do see it updating inside of Unity as well, which again is a really interesting sort of workflow, because there are advantages to working in the engine, whether it's Unreal or Unity, and there are advantages to working in Houdini. And this kind of blurs the lines between those two things to some degree. So here's just an example of using the Python states that obviously can only exist inside of Houdini. They can't really live inside of the Unity engine at all, but nevertheless, you can interact with them in Houdini. So again, creating this hybrid workflow where the advantages of Houdini are used in Houdini and the advantages of Unity are being used in Unity. So you really get the benefit of both sides by having this sort of clear line of communication between the two worlds. So if we're going to talk about processing large amounts of data and sending it around, PDG is obviously a good place to start thinking about integrating into your workflow. And for Houdini 18.5, we've tried to make things a little more accessible. We've cleaned up the UI, and we've made some other improvements along the way. So let's take a look here at some nice little UI and UX improvements. So first of all, here's this nice asset that's actually available in the content library to be downloaded. It publishes shotgun assets. And basically, you can see here a couple of things. One, improvements to the network itself and how we display information. So collapsible entries, printing information into the middle mouse button data to give you as much information as possible, but also showing cooking information in the host network. So here it is inside of SOPs, for instance, seeing the work items, the progress, and so on. So this is a really big help for people who use these sort of integrated workflows between SOPs and PDG, and really need to keep a track of what data is being used when, what's cooking, what work item is active, and so on. And of course, we've also worked on performance. So we've already made some significant performance upgrades to PDG, and that's sort of just continued. Here you can see this ROP fetch service getting a huge speed boost over the previous version without this service. So that's a really nice benefit, much faster to generate these work items and process them. We've also added a lot of new nodes for dealing with partitioning. We've improved partitioners, and we've also added new workflows for dealing with frame ranges, which can be really important for film workflows where you have multiple frame ranges overlapping. Perhaps you even have sort of local frame ranges that need to be embedded into sequence level frame ranges. And dealing with all that complexity can be a challenge previously. So we've added a lot of new tools to help you deal with these frame range issues inside of TOPS and PDG. And since we talked a little bit about performance, here's a way you can actually debug your scene and look at the performance of your graph. You could visualize these things as color previously, but the performance monitor didn't really understand TOPS and PDG, and now you can see it working exactly like the SOP performance monitor, giving you a lot of information, helping you debug what parts of your network are slowing things down, what parts are going well, and just keeping a track overall on the performance of your whole network. Dynamics have always been a huge part of Houdini, and again, it's a fundamental piece of what Houdini is capable of and what it provides users. And so with 18.5, of course, we want to continue that trend. But like a lot of the other areas of Houdini in this latest release, it's about offering new technology, but also improving existing technology to make it easier to use, more intuitive to use, and to let the user get to where they need to go faster. So let's take a look at some of the new features. FEM. FEM is a powerhouse solver, a true sort of physical solver. It gives you incredibly realistic, believable results for all sorts of material types. But it was sort of lacking a little bit in some of the types of constraints you could use with it. So in 18.5, we have these new attach constraints and sliding constraints. So obviously attaching these sort of tubes to the sphere, but also these sliding constraints, so that attached geometry sort of moves along the surface as if it's constrained to the surface. And this really opens up a lot of possibilities for this solver. Again, adding that true physical believability you get from an FEM solver with these really cool constraint types. And so obviously this is sort of an interesting, almost tech demo of the possibilities. And here's a really interesting example one of our TDs put together of this character's skin sort of melting off, falling off. But what is interesting here again is this idea that this is an FEM simulation. So the skin really has this almost fluid dynamic quality to it that would be really difficult to get from a cloth solver, for instance. Let's take a look closer up. The other thing is that there's volume here, right? This isn't just a skin. It's not just the outside. This is, it's meat. It has volume. And so FEM is really suited to this. And it's really interesting to see the combination of this very physically correct solver with this constraint where it wants to stick or slide along the surface of whatever it's constrained to. So I think people are going to come up with some really, really interesting effects using this new tool. Maybe not all is quite as gross as this. Viscosity. Viscosity, when you're doing fluid simulations, is costly. And anything you can do to speed that up would be hugely beneficial. And so in Houdini 18.5, we have the new adaptive viscosity solve. So here's just an example of some fluids with different viscosities all interacting together with the various timings. So you'll see some cases have pretty dramatic improvements in performance and others sort of medium or almost none. And of course, being an adaptive solver, that's to be expected. It depends on how adaptive the viscosity is. The more you can take advantage of that adaptivity, obviously the better the performance would be. But you can see some nice gains in certain places, but also as you go higher res, you tend to get better gains. So there's sort of a benefit to this no matter what, but the benefit tends to increase as A, it becomes more adaptive, or B, you get to longer and longer sims where the time difference actually piles up over time. And here just another example showing different settings, different sims, and the sort of gains you can get one way or the other using the adaptive viscosity. And again, keep in mind that you're not losing anything in terms of quality of the result. The fluid sim still behaves the way you would expect it to. You're not losing anything by having this adaptive viscosity. There's just a potentially very nice gain. You can see 25% faster, 33% faster, 35% faster. So there's a lot of gain to be had here without losing quality or accuracy of the simulation. So again, a really nice tool just to really help with some of these more challenging, highly viscous simulations that people are using with the flip solver. And Vellum. Vellum has actually been around for a little while now. It's a very solid solver with lots of possibilities. And so some of the focus here has been, well, again, let's make things a bit more accessible to people now that it's out there and it's working. So we've added to our content library a bunch of different Fabric, essentially presets. It's a way of getting directly to a result that you want faster. So here we're just going through a couple of different examples of wool, leather, just to sort of show the different examples that will be available to you to download. But let's take a look, on some animation, which is more likely how you'd be looking at it, on a person rather than just sort of a tube. You can see some nice results here from this animation of this dress. And now let's take a look with using some of these examples. And again, you get that nice feeling of the actual material, right? That the simulation actually is plausible to some degree, that it's actually following physical laws. It looks like a real piece of material of these various types. Of course, the shader helps quite a bit, but you can definitely see that, for instance, this sort of vinyl or plasticky sort of dress compared to sort of the wool dress. So again, really interesting, nice results here. And then all of them sort of combined together with this character walking. You can see the strings on the hoodie, the little buckles and chains and things on the backpack, the leather jacket versus the hoodie underneath. It's a very believable simulation altogether, again, using the same presets that you'll be able to download from the content library to get you up and running really quickly on really nice Vellum sims. So what you're seeing here is something really interesting and kind of new for Houdini, which is that this is a Vellum simulation running sort of interactively in the viewport. Here we've got about 40 to 50,000 hairs or blades of grass in this case being brushed interactively. This is something that we are now calling the Vellum brush. It is a tool that lets you interact with a simulation sort of live. The Vellum sim is running. You can see the grass sort of interacting. It relaxes, it moves around, gives you really nice performance. And this is really going to open up a lot of interesting possibilities here. And it's worth noting, I think, that it's working with, for instance, wires or fur or hair in this case. But it can be used with other things. So this is a soft body, for instance, manipulating this tree. And the brush has a lot of interesting possibilities, like pinning things so that they don't move, creating a snapshot of the rest state, which just happened here. And so this tree is now sort of maintaining its previous position. It wants to snap back to where it was rather than stay bent. And so this brush is not just a fur brush or a tree brush or a tet mesh brush. It's almost all of the Vellum constraint types are supported, excluding grains, which we'll probably try and look at in the future, but for the moment is not available. So let's take a look at a cloth example here, because the brush isn't just about grabbing things and moving them. It actually has a couple of different possibilities. So here we're using kind of a ruffle or a crease brush to basically change the sort of length of the constraints here to create this crumpled effect, or almost as if there are seams along these areas that we're brushing. We also have compression or expansion brushes. to pull or push things apart. You can see you can get some really nice looks there by doing that, kind of almost inflating the material, pulling it apart. And then you can actually smooth things back down to its rest state. So again, keeping things nice and interactive. There's also a twist brush, so you can take the cloth and twist it together to give sort of some interesting results. And of course, you can grab and move things around after it's been twisted to sort of untangle it if you need to. And you can see that you're able to really manipulate this even with this high resolution cloth and get some nice interactive results from it. We're going to fold this cloth over now just to sort of show how you can work with this in 3D. And then we can pin the edges of the cloth, similar to what was done in the tree example, and then actually move the simulation forward in time. So it's not just this static version of the brush. You can immediately jump over to a simulation, a sort of simplified simulation, to get some really nice results and still interactively edit, move those pins, edit those pins, drag them around while the sim is actually playing live. So again, it's not sort of sitting in this static state. You can choose to have a live simulation running in the background so you can see these sort of live updates, or you can work in this highly damped, zero gravity environment for when you're doing more of a sculpting or brushing type interaction. And both of them allow you to get to really nice results pretty quickly. And as you can see, the playback is pretty fast, and it's falling sort of slowly under gravity because we have a bit of a reduced gravity in this simulation, just to make it a little easier to work with, slightly more damped than you would get for a real cloth sim. And just to drive home the point that this is multiple types of interactions, here we're going to take a cloth sim and some soft body objects, and we're just going to mix them together. And suddenly the possibilities for set dressing become really interesting. We'll just take this sort of drop cloth, push it around against this collision object, and then start adding things like these sandbags. We can rotate them around. And again, using pinning, using the different brush types to stay in this sort of interactive state and give you some really interesting possibilities here. Modeling something like this is obviously possible, but again, nothing sort of gets you there faster than being able to simulate the result. And the fact that these different types of objects, soft bodies and cloth, hair, can interact together in a single vellum brush simulation is really, really useful. So let's say we've stopped here, we like what we've got, and now we want to add some extra detail. So what we've done is move to a secondary simulation now, where we've turned everything into cloth. So whereas we had a soft body before, now we're just manipulating the shell as cloth in order to add wrinkles in places. You can see occasionally we're grabbing snapshots to sort of freeze the cloth into a certain state. So this lets you sort of act in passes, work with a simulation, get things generally into the shape that you want, and then basically layer simulations on top of simulations, or in this case, these vellum brush sims on top of each other to give really nice, fast results in this very interactive way. And obviously, looking to the future, this type of real-time interactive result is going to show up more and more frequently in our tools. You saw it with the last release with some of our tools in Solaris, and it's starting to show up everywhere. Here now another example using a tet mesh. So this is sort of a soft body. We're just manipulating this pig almost like he's made out of, well, pig, I guess. Maybe a boneless pig. But we're also able to do things like create these snapshots. So this becomes the new rest shape, what we're building here. So when we move the simulation forward and actually play it, you see that it kind of, again, much like that tree was resisting bending, the pig's nose and ears are trying to kind of stay in place, kind of stay where we put them. So there's, again, a lot of possibilities here for manipulating things in this sort of physical way. I wouldn't necessarily go so far as to say it's a sculpting tool so much as it is almost a posing tool or a clay kind of tool, I guess. But again, really nice, really fast interactions, and it's always fun to play with the pig head. So let's move on to Pyro. Obviously, again, Pyro, a very important part of Houdini, and we wanted to push this forward again. We recently introduced the sparse Pyro solver, and what we're introducing now in Houdini 18.5 is what we're calling the minimal solver. And so the minimal solver is meant to be a interactive fluid simulation tool. So here, this is playing sort of live in the viewport as I manipulate these sliders. And the idea here is to give you very, very fast results so that you can sort of plan out your simulation, get the settings that you like, set it up exactly how you like it, very, very rapidly. We're able to go to very high resolutions and stay at, I wouldn't necessarily say interactive speeds at extremely high resolutions, but still quite fast, 1 to 2 frames per second for very high resolution simulations. Now, this is obviously quite a bit more low res, and it's playing back quite quickly. You can't entirely trust the FPS there at the bottom, as it sometimes exaggerates or underestimates or overestimates, but it's a good guide. And you can see that we can manipulate this simulation greatly from where it started and dial in those settings exactly how we want, which is the goal of the minimal solver. And to go along with it, there is the simple GPU explosion. This is all running on the GPU. That's the goal of the minimal solver. And you can get some really nice results along with our new Pyro shader, which we'll talk about in just a bit, to really bring out as much detail as possible and really make your sim look as nice as it possibly can. So now let's take a look at an actual workflow here. We're going to use some tools that we're going to talk about in a little while, but this is a whole new workflow we've introduced with these Pyro burst tools. And what is the Pyro burst tool? Well, basically it's a tool set that mimics what a lot of effects setups tend to be, which is quite often particle sims that just explode outward, giving sort of an interesting shape to be used as more or less an initial state for a Pyro simulation. And so this tool is designed to kind of give you that in real time, in SOPs, without having to go to a simulation, using all the standard sort of tools that we have to do this. So again, this is designed to get you to where you need to go faster. This is likely a tool you've either built yourself or a setup that you constantly rebuild in order to get this. So right away, we can hit play now. We're using the minimal solver here, and you can see we get, maybe not a very exciting result, but you can see how quickly we got this result into the viewport. So let's go ahead and play with some of our settings here because this is simulating back so quickly. So first of all, let's add some smoke so we get a bit of a nicer sort of bang there. Let's increase the density a bit, make it feel a little bit fuller in the viewport there. And then we'll reduce this dissipation so we get more of a sort of a cloud of smoke. Now we're starting to get something kind of interesting. And you'll notice that most of the options that are available to you on the sparse solver are available in the minimal solver. So you can add disturbance, you can shape this the same way you would shape your regular simulation. It's just a faster turnaround time. And so quickly, we've gone from a very, boring simulation to something that looks a lot more interesting. And so we can tweak the dissipation now, and now we have a nice little sort of smoke explosion there. So let's take this a little bit further. We're going to add a new tool called Pyro Trail. And the idea here is to create those sort of long trails that you typically see in explosions like this, but again, do it in SOPs. Rather than having to build a particle system to do this, instead provide this as geometry. So not only can this be used, by the way, as an input to Pyro simulations, it can be used as geometry, as something to almost model with if you wanted to. But of course, in this case, what we're trying to do is create some nice sources to add those sort of smoky trails to our simulation. An interesting side note is that these can actually be really nicely used directly as part of your explosion without doing a simulation, because how you can sort of shade them into the shape of these trails. But here we go. So now we've got a nice little pyro bang. a couple of little trails shooting out the side. That's pretty nice. So this basically gives you a nice fast setup, but let's take it, even further now. Let's say, well, I don't want one explosion. I want, a whole bunch of explosions. So I'm just going to draw a trail here inside of our pyro container, do a classic sort of Houdini manipulation, just resample it into a couple of points. And right away now we've got a different pyro burst and a different trail for every one of our points on our path. So again, let's jump down to our pyro source and hit play. And now you can see we get all of these things exploding at the same time, which is pretty interesting. We've gone from not very nice simulation to a large scale simulation at a pretty decent resolution as well. There's enough detail there to actually evaluate what you're doing. Now let's take it even further than we did before. So we're going to go ahead now and use an attribute expression node to create a start frame. And basically we're just going to randomize a start frame based on each point. So we're going to create a range of values from 0 to 1. We're going to remap those values to 0 to 55 using the attribute remap node, and then go ahead and plug that into our pyro burst nodes. And basically what this is going to allow us to do is say, instead of just making a burst per point, do that, but offset them in time. And again, just using an attribute. So much like some of the other tools that we've talked about, this is a high-level wrapper around a workflow, but it doesn't prevent you from using any of the standard tools that you use in Houdini to really get the most power possible out of it. So here now, playing back in this sort of interactive state is this now offset simulation of these explosions. And this is something that absolutely you could have set up before, but by having this interactive pyro sim along with these tools for doing the shaping, you can get really nice results very quickly with a minimal number of nodes. And then finally, just to dial in the look, we're going to go ahead and add our pyro bake volume node, which basically gives you our new shader, which works in the viewport and of course at render time. And it really helps you bring out interesting detail in your simulation that was difficult to get previously with our previous shader. It took a lot of work. Now you can get it not only looking really nice in the viewport, but obviously you can get it looking really nice at render time as well. And so let's just go ahead and throw down a flipbook to get a look at how this looks with the shader applied. You'll notice it's a little bit slower than the real-time playback you had before because this shader is pretty complicated. It's doing a lot of stuff under the hood. But pretty quickly you can get a really nice result really quickly. And let's just take a look at the result. And keep in mind, this is just the viewport. It hasn't been rendered. It really is just the output of the sim we were just looking at. And of course, the beauty of this setup is that, you can take those same principles now and apply it to something very large scale, something that could never fit on your GPU, billions of voxels, enormous amounts of detail over a long period of time. And that's really the benefit of this, that this minimal solver becomes a way of rapid prototype, rapid look development before sending your simulation somewhere to scale it to proportions that are just not possible on a GPU, at least current GPUs. And again, you can see just the huge amount of detail that's in this simulation, but as well the nice benefit of having this new shader, to really pull out a lot of that detail. So let's just take a look again at these trails. So here we are just showing just the trails, and you can see we can add some noise. And this system, this burst and trail system, is at the heart of almost every pyro explosion. And so this is, again, a really nice wrapper around that tool set. And the output of a simulation like that, shown from this camera angle now, can look really incredible. You can see the bright sparks on the ends of the trails. Just a huge amount of detail in this simulation. And again, this is the viewport. This is the new shader being rendered here just using the viewport. So you can get very close to your final result in the viewport. High detail, really interesting results using these high-level tools for an artist to shape the result. And then, of course, a render being the sort of final pass that really gives all that beautiful sort of internal lighting, all the stuff that a full render will give you, where you see this real beautiful illumination of the fire within the smoke. Again, pulling out all of the detail that you worked so hard to get into the simulation in the first place. But these trails are sort of necessarily used by themselves. So really they're meant to be sort of potentially even chained together. So here you're seeing this sort of rapid explosion of these bursts, creating these sort of secondary explosion inside the original one, as well as there's the trails being spawned sort of almost on a tree, a spine along the inside of this sort of volcanic explosion. And again, so the idea is not to give you a single look. It's not just about this one type of thing. It's about empowering you to create dozens of different kinds of things, but using the same base set of nodes. And because this is all living in SOPs, instead of having to be, a pop solver or something external, you can actually manipulate this even further using standard SOP tools and SOP workflows. So again, it's taking what was entirely simulation set up previously and moving it closer into our familiar world of SOPs, where you have a huge number of tools to help you get the result that you want. And so I've been saying that this is sort of a replacement for a simulation, which it really is, and it can do things that you typically expect to have to use a simulation for, like collisions. So again, this is all SOPs, it's all updating sort of in real time, but you can get these things interacting with objects. And so you can create complex results. It's not this simple tool that does one thing. It really is a robust tool set meant to give you many different looks. And once again, just at a scale that is just incredible, really, when you think about it. Billions of voxels, just huge amounts of detail, basically covering this entire sort of city block here with smoke and fire. And so a lot of times when we introduce tools like this, what happens is people will come to us and say, like, these tools are great, but we don't know how to use them yet. We need to get up and running. And so we've included shelf tools to come along with this. And these shelf tools give you, usable results. These are not toys. You can see the network is not hugely complicated, but it's complicated enough to give you a really, really nice result. And it shows you how to use the shader, how to use these tools in conjunction with each other to get something that you actually would want to use. These tools are meant to give you real results. I can't necessarily say they're production quality results, but they're very useful results to get you started and to take them to that next level, which is, of course, what your job as an artist is. There's an aerial explosion, which is just another preset. And again, we're showing just the possibilities here using these tools and how you can get these really nice results, and then providing you with shelf tools to get you there faster. And we also updated some previous tools. So there was a fireball tool in older versions of Houdini that's now been updated to use the new setup as well as the new shader to go along with it. And again, the shader allows you to sort of pull out lots of detail in the explosion, stuff that's always been in the simulation, but it took a lot of work to pull it out. You can see the nice crispy edges, the sort of black soot on the outside of the fireball. Really, really nice stuff. And now very achievable using this new shader and new pyro workflow. And of course, it's not always massive explosions. Sometimes it's bonfires or smaller things on fire, and we want to provide you with some nice tools for that as well. So really just trying to round out the tool set and give you lots of examples to give you a sort of vector of approach for whatever effect you might be working on. So just to end off here, just because these are really cool looking simulations, we've got a cool sort of flamethrower here, looking really nice, really high res, really super detailed. And finally, I've sort of run out of tricks. Here's our final explosion to end off this section on dynamics in Houdini 18.5.
All right, Scott, thank you. That was awesome as always. So folks, we're almost at the end of our show. Houdini 18.5 is going to come out in just a couple of days, October 20th. Hope you enjoy it. And it's going to come out with all the features that you've seen and a few more. We can never capture them all in our little presentations, but hopefully you will all enjoy them as users of 18.5. There's lots more there. Hard to name a particular one. I'll just pick one randomly. Many more compiled SOPs to make your SOP productivity even faster. And on the side effects lab side of things, look for a lot of tools there that are not just for game development. Everyone in film, games, commercials are using our side effects labs tools more and more. There's a lot of good stuff in there. And of course, the big question at the end of the day is Houdini 18.5 ready for Python 3.7? And the answer is yes. All right, let me finish by thanking our wonderful R&D crew and everyone at Side Effects who made this possible. Our R&D team, that's developers, QA, documentation, TDs, and an ever-growing list of interns, have outdone themselves. Their creativity and their drive, once again, have found no bounds. And even more so, incredibly, in a year like this, they're able to outdo themselves even beyond that. They had some pretty major features ready early on. I'm talking about session sync and topo transfer and some of the FBX features. And they were ready early enough for us to be able to backport them to Houdini 18 in July so you can enjoy them throughout the year. So fantastic, fantastic job to all of them. And also, finally, a big thank you to our alpha and beta testers who are with us from beginning to end. Hopefully, they'll come back. Without them, we wouldn't have a release as robust and polished and ready for production as we hope you'll find it. So thank you all. Enjoy Houdini 18.5. Thank you, everyone. Enjoy.
Thanks. Take care. See you soon.